Welcome to the class, student. Today we are going to discuss increasing decreasing function, right, and maximum minimum. You see here, what is mean by increasing function? Increasing function. See here, increasing functions are two types. One is strictly increasing function. Another one is non-decreasing function. Right? Increasing functions are two types. One is strictly increasing function, the other one is non-decreasing function. What is mean by strictly increasing function? See here, a function f of x is said to be, right, strictly increasing in a comma b, close interval a comma b, which is a subset of domain of f, okay. If condition you see here, x1 is less than x2 implies f of x1 is less than f of x2, right? Or else you can say like this also, f dash x is greater than 0 for all x belongs to a comma b. For all x belongs to a comma b, then you can say that strictly increasing function. Example is like this. Graphically, how can we tell? We can tell like this. Suppose if I take like this, graphically, this is a, this is b. You see here x1 and here it is x2. This is f of x1. This is your f of x2, right? You can tell like this. Now you see here, if you classify this strictly increasing function, what is that? Strictly increasing function. If you take here f dash x is greater than 0, you have three choices. Three cases are going to be arise. What are those three cases? If f double dash x is greater than 0, and f double dash x is less than 0 and f double dash x is equal to 0. If f double dash x is greater than 0 means, see here, it will be concave up. The diagram is like this. This is called concave up. Concave up, you can say. Now it is also increasing. No doubt that it is also increasing. But the question is, this is concave down. Right, this is what? Concave down. You can say that concave down. What about this one? It will be like this. Okay, it will be like this. Right, another one I said it to you that non-decreasing. Non-decreasing I said. Non-decreasing function. What is non-decreasing function? You can write like this. A function f of x is said to be, okay, non-decreasing function, okay, in close interval a comma b. You know very well that this is subset of, it is a subset of domain of f. Okay, if condition you see here, if x1 less than x2 less than x3 less than x4, right, implies f of x1 is less than f of x2 is equal to f of x3 less than f of x4. Or else you can simply, you can say for all, you see here, for all x1, x2, x3, x4 belongs to a comma b. Right, or you can say that simply f dash x is greater than or equal to 0 for all x belongs to df, or you can say that a comma b, close interval a comma b, you can say. Diagrammatically I would like to explain. I am trying here. Diagrammatically I would like to try to explain. You see here, it will be like this. And certain part of interval, okay, it will be like this. See a, this is x2, this is x3, this is x4, and here it is x1. You know very well that f of x1. You see here in the diagram, almost all these two are equal. F of x3 here f of x2, and this is f of x4. Almost all they are what? Equal. So now increasing function is two types. One is this, another one is this one we discuss. Now you see here, in the same way we can discuss decreasing function also. What is mean by decreasing function? You see here how I am going to define a decreasing function. Okay, decreasing function. Decreasing function is also what? Two types: strictly decreasing function or non-increasing function. You see here decreasing function. What is that? First one is strictly decreasing function and non-increasing function. Non-increasing function. Non-increasing function. See, strictly decreasing function. So you can define like this: a function f of x is said to be, right, strictly decreasing function in a comma b, which is subset of d of f, domain of f. If condition you see here, if x1 is less than x2 implies f of x1 is greater than f of x2. For all x1, x2 belongs to what? Close interval a comma b. Right, for all x1, x2 belongs to this one. Or simply you can say that f dash x is less than 0 for all x belongs to a comma b, then you can say that it is strictly decreasing function. Example, here graphically I would like to draw like this. If it is like this, this is b, this is a, this is x1, this is x2. This is f of x2 and this one is f of x1. Right, you got it. Now here also you can tell what is that. You can classify here this one also. Strictly decreasing function also you can furtherly classify f dash x, f double dash greater than 0. F double dash is greater than 0, sir. This is less than 0, no doubt. F double dash x is less than 0 and f double dash x is equal to 0. What happened here? See, double dash means it is concave up, but it is decreasing. No doubt that it is decreasing, but it is concave up. How? It will be like this. See here, concave up. This is A, this is B. Okay, concave up. Okay, up. Whereas here, concave down. How it is? Yes, sir. No doubt it is decreasing, but concave down. It will be like this. This is A, this is B. It will be concave down. And the next one you see here, in this case, in this case you will get like this. This is what? B, this is A. This is like this we will get. Now I said it to you that non-increasing function. Instead of this non-increasing function, how I am going to define a function f of x is said to be non-increasing. You see here, non-increasing function, right? Function in this one, same as it is, but exactly opposite. This one, sir, exactly opposite. Whereas here, in another one, we can say that f dash x is less than or equal to 0 will get. This diagram is quite opposite. How it is? You see here, right? I would like to draw in this way. Yes, sir, quite opposite, sir, like previous one. This is A, x1, this is f of x1, this is f of x2. You see here, approximately these two are same, right? These two are same. As goes on furtherly to reach B, you will get in this way, right? Strictly increasing function will get. Okay, you see here one question is there on strictly increasing function. What is that? F of x is equal to x by 5 plus 5 by x is there, and he said that increasing. What you are supposed to do? You can do like this, f dash x, just you differentiate. If you differentiate here, 1 by 5 you are getting, whereas here 5 by x square will get, sir, minus. Now what I said it to you that increasing, strictly increasing you can consider because all our open intervals are there. So f dash x is greater than 0 means 1 by 5 minus 5 by x square is greater than 0, or x square minus 25 by x square is like this. simply this is what cannot be 0. So x minus 5 and here x plus 5 greater than 0 we can say. So what you will get here after plotting this one on the number line, yes, no, yes. So x belongs to minus 5 to minus infinity to minus 5 union 5 to infinity. But here he has given that. But in the question he has given that x cannot be negative. X cannot be 0. Yes sir, we got it here. X cannot be 0. We got it over here. You see this. Okay guys, you see here the condition that, this is the second problem we are doing. The condition that f of x is equal to that one is increasing function for all x belongs to R is, he has given 4 conditions. Now you see here when he said that increasing function, you consider as strictly increasing function. Just you differentiate 3x square plus 2ax plus b plus 0 greater than 0. But that means what? 3x square plus 2ax, 3x square plus 2ax plus b, we got it, is greater than 0. Now you see here a quadratic equation. This is what quadratic expression is greater than 0 when it is possible for all real x it is. Then this definitely this condition holds good. Discriminant. What is the discriminant here? 2a whole square minus 4 into 3 and b, that is equal to greater than 0. B square minus 4ac. If ax square plus bx plus c is a quadratic equation, the discriminant is what? B square minus 4ac. So here b square means 2a, 4ac, we got it here. Now see, a square minus 3b is greater than 0. That means a square is greater than 3b, we got it. You see here, a square is greater than 3b we are getting. Strictly increasing function. Right, strictly increasing function means, right, strictly increasing function here, sorry, it is always, so you see here, I committed a mistake here. In this case, definitely I committed a mistake. What is the mistake here? Here, a quadratic expression completely above x-axis. This is the mistake I committed here. 3x square plus 2x plus b is greater than 0. Whatever it may be the value you are substituting, you are getting what? Positive. If it is x-axis, then I have to write here less than 0. That is a mistake I committed here. Sir, if you write here less than 0, see this? I can get it here. This is the perfect answer. You can cross check like this. A quadratic expression, because 3 is there, a is equal to 3, greater than 0. Greater than 0 means up is direction, x-axis, everything above, not going to cut, not going to touch. For all values it is positive. Therefore you can say that discriminant is less than 0. Discriminant is less than 0 means we are going to get a square is less than 3b. Now you see here one more question I have taken. F of x is equal to tan inverse of sin x is increasing, he said. Increasing means what I am doing here, just I want to differentiate. With the help of differentiation, I will get like this. It's a chain rule, sir. Okay, tan inverse x derivative 1 by 1 plus x square and sin x derivative is cos x will get. As it is increasing, f dash x is greater than 0, that is cos x divided by 1 plus sin x whole square is greater than 0 means, yeah, you can write here just cos x is greater than 0. Simply you can say that cos is positive when from here to here, minus pi by 2 to pi by 2. So x belongs to minus pi by 2 to pi by 2. But you see here, don't think of this. Okay, for every rotation you will get like this. That means here I can write here 2n pi. If I add to this is perfect answer you will get plus pi by 2. Right, what is that? N belongs to I, you can say. So my answer is this one. Okay sir, right, be careful. Now you see here, I have taken example on decreasing function. F of x is equal to like this he has given. As you know very well that decreasing function means simply you can differentiate here like this. If you differentiate here, you will get here 6x square and 30x plus 36 you are getting plus 0. When he said that decreasing f dash x is less than 0, all are open interval, you can consider as strictly decreasing function. So f of x square 30x plus 36 less than 0 or x square minus 5x plus 6 less than 0. X square minus 3x minus 2x plus 6 is less than 0. So x minus 3 and x minus 2 less than 0. X belongs to 2 to 3. X belongs to 2 to 3 is a right answer, sir. You see here, another example I have taken here. F of x is equal to like this he has given. That means what I am doing here, f of x is equal to he has given sin x minus cos x minus ax plus b has given. sin x minus cos x minus ax plus b as given. Now if you differentiate here with respect to x, you will get f dash x. This is cos x plus sin x minus a plus 0 you are getting. The moment he said here decreases, f dash x is less than 0, cos x plus sin x minus a is less than 0. That is what finally cos x plus sin x is less than a. The maximum value of this, you see here, maximum value of cos x plus sin x is root 2. Right? Okay, you see here, what I did here, maximum of sin x plus cos x is this one. Because we know the formula, a cos x plus b sin x plus c is there. The maximum of this one means under root of c plus under root of maximum. This is maximum of the c plus under root of a square plus b square. By using this formula we got it. So I can say that root 2 is less than a, or a is greater than root 2. This is the answer. Okay, we'll go on to the next one. See here, one of the good question I have taken here. F of x is equal to a square minus 1 by a square plus 1 into he has given like this, and he said that it is decreasing function. The set of all possible values of a which does not depends on x is set. This is very interesting. F of x is equal to, see here, a square minus 1 by a square plus 1, 3x square. I started differentiating over there. So 3 plus 0. Now what he said here, f dash x decreasing means like this. Now you see here x square, a square minus 1 by a square plus 1. Okay, here x square minus 1 is less than 0. Or else x square minus 1 x square after taking LCM, a square plus 1 is less than 0. Now it is very clear. You see here it is negative. When it is negative, anyhow a square plus 1, whatever it may be the value of a, you substitute here. This is what definitely minus of a square plus 1 is negative. Then the question is arising for this. X value whatever you substitute, because x square is positive. The only one thing is this total equation is now depends on this one. If this is negative, overall negative, we can say. That's why this is one of the really good question it is. You can say now. Yes, here a square minus 1, either this one is 0 or it may be negative, then you can say that it is negative. It may be 0. If it is 0, not depends on means 0. Nothing will happen. This is what negative. Yes, absolutely right. If it is negative, this is whatever it may be x. Okay, if even though x is 0, nothing will happen. It is because it's satisfying. Either 0 or this one. This is 0 or it may be some less than 0. Then you can say that. That means what? Here a minus 1, here a plus 1 is less than or equal to 0. You see here after plotting this one, this is no, yes, no. You can say that a belongs to minus 1 to 1. Simply you can say. This is one of the good question we have taken now. Interesting question. See here f of x. Here he has given if x is greater than 0, which of the following is true? You see that 4 options A, B, C and D. 4 options are given. If you observe carefully, 4 options are same, because you can take here same means I can define the function like this. Here tan inverse x minus x by 1 plus x square I am taking. Tan inverse x minus 1 by x square I am taking. How can we, whether it is increasing or decreasing? You are to judge what is going to happen. You see here, if you are differentiating this one, you will get here 1 by 1 plus x square minus here u by v formula I am applying 1 plus x square minus x, here 2x divided by 1 plus x square whole square we are getting. Now we are supposed to judge. It is our hand, in our hand. So what is that? What we are getting here? 1 minus x square divided by 1 plus x square whole square we are getting. 1 plus x square minus 2x square, sir. Now after taking LCM, 1 plus x square whole square, you will get here 1 plus x square minus 1 plus x square you are getting. So 2x square divided by 1 plus x square whole square. Guys, you can say that. See Nana, it is very simple. Whatever it may be the x value substitute, and that to what he has given positive values. All our squares are there. Definitely we can say that f of x is greater than 0. If f of x is greater than 0 means what? Tan inverse x minus x by 1 plus x square is greater than 0. That you can write as tan inverse x is greater than x by 1 plus x square. You can mark this one. I think the first one is the right answer. One more interesting question you see here. if 0 less than x less than pi by 2. He has not discussed, he never used the word increasing, decreasing. He has given the options like this. So carefully you have to identify the function first of all. What is the function here? You just observe all the four. Yeah, I would like to able to identify that my function is f of sin x by x is there. And he compared with different one. 1, 2, pi by 2, 2 pi by 5, etc. Now what I'll do here, I would like to differentiate first of all. What is that? Whether it is greater than or less than, I can identify in the interval 0 to pi. So that's the reason I am differentiating here. If I differentiate here, u by v formula, cos x and x you will get minus, here it is sin x as usual, x derivative is 1 divided by x square. See here, f dash x is equal to x cos x minus sin x by x square. Definitely there is no second thought in that. For x belongs to 0 to pi by 2, definitely this is less than 0 for all, right? This is less than 0. It is, if it is less than 0, you know very well that it is less than 0, you know very well that what is the x he has given? X is less than pi by 2 has given. You can write this one as f of x and f of pi by 2. What relation is there in between these two? You are having this relation, it is increasing. F of x is greater than what? F of x is, it is less than 0. Decreasing means the beginning is what? Big values. At the end is what? It is going to take small values. That means here we are getting sin x by x. Okay, and here you substitute pi by 2 in this one. Sin pi by 2 by pi by 2. What you are getting here? Sin x by x is greater than 2 by pi you are getting. See this? Like this also we can do. Okay, the next concept in this one is stationary point. What is stationary point? Or people are going to the point of extrema also, you can say. Stationary point, point of extrema, and you can call it as what? Turning point also. Right, the name. Here I'm using the word. Instead of saying that here, you see a turning point, right? Or else you can say that point of extrema, point of extrema. You can say like this, stationary point, turning point, or point of extrema. What is the definition here? Wherever that f dash a is equal to 0 for the function y is equal to f of x, then that function is said to be what? Stationary at x is equal to a. Because f dash x is equal to 0 at x is equal to a. Then f of a is called its stationary value, and the function is what? Stationary at x is equal to a. Now what is the stationary point means? A comma f of a you are supposed to write. That is called stationary point of point of that function f of x. One example I have taken here. A stationary point of f of x is equal to this one. What is that? See here. If you differentiate here, you will get minus 2x divided by 2 root to 6x square. Like this you are getting. Right? If you equate it to 0, because he said here f dash a is equal to 0. Let us say that it is equal to 0. If it is equated to 0, x under root of 16 minus x square equal to 0 means x is equal to 0 you are getting. Right? X is equal to 0 you are getting here. If x is equal to 0, once you got the value here, x is equal to 0, then f of 0 is how much? Under root of 16 minus 0 square is nothing but 4. So 0 comma 4 is a stationary point. Okay, stationary point. What is a stationary point means? Like this we can go for stationary point. Yeah, I have taken one more example. You see here, f of x is equal to, he has given here. What is that? F of x is equal to, see here I would like to solve this one. Sin inverse x whole square plus cos inverse x whole square is there. Now you see here, yeah, I would like to differentiate here. After differentiating, I may get here 1 divided by, okay, sin inverse x here and under root of 1 minus x square, whereas here minus you will get cos inverse x and divided by under root 1 minus x square you will get. As you know very well that to find stationary, what you are supposed to do? F dash x is equal to 0, you go for it. You will get here sin inverse x is equal to cos inverse x. This is possible only for at x is equal to. Where this function is stationary means this one. And the stationary value means you have to substitute in this one. And whatever you will get, that is your answer. So now where the function is stationary means x is equal to root 2. So here I am using the word critical point. Now you see here you may get, after this definition you may get confusion. Stationary, turning point and point of extrema and critical point. How? Sir, in that definition and this definition everything is same, but one extra point is there here. Right? One extra point is there. Suppose if he has given that critical point, you have to take care of this word also. What is that? Same as it is, a real valued function on the domain of D. Okay, let us say that A belongs to domain. In that domain A is there, f of x is said to have a critical point, okay, at x is equal to A, if f dash A equal to 0. F dash A is equal to 0, we said in stationary point also, in turning point also, in the case of what? A point of extrema also we said it. But one more is there. What is that? F dash A does not exist. Here in critical point means you have to take care of this one also. Wherever this function is, given function is, okay, given function derivative is not going to be exist at a certain particular point, those point also you have to count. Right? So to find the critical point of this one is said. What I am doing here, you see, solution. Here f dash x. F dash x is what? 2 by 3. X minus 2 all to the power of 2 by 3 minus 1. 2x plus 1. UV formula I am using. Nothing. I am using here UV formula. You see that? I am using here UV formula. And the other one is here x minus 2 all to the power of 2 by 3. And this is what? 2 we are getting. Now you see, sir. Here if I take, if I write here 2 by 3. Here 2x plus 1 divided by x minus 2 all to the power of 1 by 3 you will get. And whereas here 2 into x minus 2 all to the power of 2 by 3 is there. If you take LCM, sir, if you take LCM, 4x plus 2 divided by, here it is 6 into x minus 2 will get, because 2 by 3 plus 1 by 3 power is what? 1. And here x minus 2 all to the power of 1 by 3. Now you see here 6x plus this 10x. We are getting 10x. And here 12. You see this one. Here 12 we have 12 plus 2 minus 10 divided by x minus 2 all to the power of 1 by 3. The moment I said it to you that where it is defined. Now you see critical point is said. What I am saying here, f dash x is equal to 0 for x is equal to 1. You will accept. There is no doubt about it. And also you can say that f dash x is what? Undefined, does not exist. Simply you can say that does not exist where x is equal to 2. So the number of critical, what are the points are there means 2 points you can take. One at x is equal to 1 and x is equal to 2 you have to say. I have selected one more best problem. You see here x lies between minus 4 to 4 is said. The critical points of this one is said. Now you see here I would like to use, we can do like this also, sir. What is that? Here I want to avoid first modulus based on this condition. X square plus 6x plus 4 if I write minus 4 less than equal to x less than equal to 0. Till 0 you can take, nothing will happen. So x square, because mod x is negative less than 0, and next here minus 6x plus 4, here 0 less than equal to x less than equal to 4. I divided this one. Now I am using differentiation because to understood this one in a better way, I think this is good. Easily you can catch. What is that? 2x plus 6 and here 2x minus 6. Minus 4 less than equal to x less than equal to 0, 0 less than equal to 4. Now what? F dash x is equal to 0, I said one condition. When f dash x equal to 0 means it may be 2x plus 6 equal to 0, then x is equal to minus 3 will get, or another one 2x minus 6 equal to 0, x is equal to 3. That means 2 points you got it. One is this, another one is you got it. At x is equal to minus 3 it is stationary, at x is equal to 3 also what you can say that it is stationary. Right? These two are also a critical point. Now the next one is, another one is that because f dash x is equal to 0 at that point. Now another one is what? Does not exist. I said it to you that. You see f dash 0, Lf dash 0, left hand derivative at x is equal to 0. What happened here? You substitute here 0 plus 6, you will get what? 6. And Rf dash 0, what happened here? 0 minus 6, minus 6. What is this? Does not exist. Does not exist. Therefore, at x is equal to 0, f of x is what? Does not exist. F dash x is does not exist. So, how many points are there? 0, 3, minus 3. These are the 3 points where the function has what? Critical points you can say. One more interesting concept. You see here, local maxima, relative maxima. What is that? A function y is equal to f of x is said to have what? Local maxima at x is equal to a. The condition is if f of x is less than or equal to f of a for all x belongs to this a minus h, a plus h. Okay, graphically I'll explain. What is h means? Here I'm talking about neighborhood. Neighborhood of a, sir, it is. Why? H is so small quantity we are taking. It's a neighborhood. If you take the neighborhood, you see here, graphically I would like to try to explain. See here, this is maximum. this is x is equal to a. If I take here, this is what a minus h, and if I take here somewhere here a plus h, they may be equal, may not be equal, they may be different, but this is called f of a minus h. This is f of a, and this is called f of a plus h. What I said it to you that f of a minus h, condition is what? F of a minus h is less than f of a, and you see that either left side you take down or right side you take down. F of a plus h is also what? Less than f of a. Then you can say that it is local maxima. You can say that local maxima like this. In the same way, you can discuss here local minima or relative minima. Local minima, relative minima, same as it is you can write. Okay, the only thing is the condition, this condition is going to be changed. What is that? F of x is greater than or equal to f of a for all x belongs to a minus h comma a plus h. Graphically I'll explain here. No doubt, graphically I'll explain here. You see this one, it will be like this, right? It will be in this way, sir. This is a, and you take down here a minus h, and you take down here a plus h. This is f of a minus h, comparatively f of a, that is this one is greater, and comparatively f of a plus h, this is what? Less. So sir, a minus h is definitely greater than f of a, or a plus h you take down greater than a plus h. Then you can say that f of a. In both the case, you take left side or right side, it is like this. Then you can say that relative minimum. Same as it is, sir. A function y is equal to f of x is said to have local. Only thing is what? Local minima, we have to say minima at a point x is equal to a, if this condition holds good for all this one. Diagrammatically I explain here local maxima, local minima. Yeah, you see here first derivative test. What is first derivative test here? So many points I wrote here, but all are very simple, sir. Very simple. You see here, with the help of first derivative test, how can you say that the function is having what? Maximum at x is equal to a, and at the same time how can you say that the function is having minimum at a? See, they'll give like this. F first, definitely on a particular interval f should be what? Differentiable function, there is no doubt about it, and f dash a is equal to 0 is also happening. Now how can we define here? You see here it is what? Like this, positive and negative, and there it is negative and positive. Local minimum, local maxima means positive negative is there. You see here simple diagram. Diagrammatically I'll try to explain with a simple one. Very simple. You see here, this is our x is equal to a, where f dash a become what? 0. No doubt about it. You can call it as. Now you take a point here like this. If you say that theta acute, it is acute. What happened here? Dy by dx. That means I have taken here y is equal to f of x. Dy by dx is positive. Yeah, I said it, that one only. It is positive in this one, right? This point you can take here. What is that? You can take a minus delta. Chalega. A minus delta you can take down, or a minus h also you can take. Nothing will happen, right? Another one here I would like to take here after this one. This is x-axis. This is what? Theta. That is theta means this is phi. You can say that this is obtuse. Okay, obtuse. Now what about this one? A plus h. What happened here? Dy by dx is less than 0. So dy by dx is changing its sign. Okay, see here, positive to 0 to negative. That only I wrote. F dash x changes its sign positive to 0 to negative. Then definitely we can say that it has a maximum. This is what? Maximum value. Maximum value is f of a. Where it is maximum? At x is equal to a. This is called first derivative test. For maximum, okay, minimum also the same story, sir. Nothing is there. Everything is same. You see here, it will be like this. So at this particular point I'll take, and here also I would like to draw the diagram. You see this one. This is phi. Phi means you know very well that obtuse. Now you see here, here this is theta. That means what happened here? Dy by dx is less than 0, whereas in this particular case dy by dx is equal to 0. That is what? F dash x. Okay, f dash x. F dash x is positive. F dash x is 0 at this particular point a, and if you take here, this is 1. This is a minus h. Okay, a minus h, this is a plus h, you can take, nothing will happen, everything is there. Very simple. See here, dy by dx is less than 0, dy by dx is equal to 0, and whereas here dy by dx is greater than 0. Negative to 0 to positive, see here, negative to 0 to positive, then you can say that it will have what? Least. Okay, minimum value. Okay, like this first derivative test, okay, we can, first derivative test, with the help of first derivative test, we can identify minimum, maximum also. See here, nth derivative test. What is nth derivative test means? Sir, y is equal to f of x given function. You differentiate here, dy by dx, that is what f dash x, equal to 0. Say you got it x is equal to a. This is what, say, some value we got it here. After simplifying this equation, we got it a. Now, what they'll say that f double dash x. Go for f double dash x. F double dash x again, you will have what? 3 values for a. F double dash a may be positive, f double dash a may be negative, and f double dash a is equal to what? 0 also. So when f double dash a, you can say that f of x is minimum at x is equal to a minimum value is f of a. You can say like this. And here it is f of x is maximum, and at x is equal to a. If this condition exists and f of x, here you can say that maximum value, max value is f of a, you can say. Now whereas here you can't say anything, Nana. You can't say anything, but you can go for 3a, triple dash. F triple dash a is equal to 0, not equal to 0. Here, if it is not equal to 0, then you can say that no maxima, no max, no mini. No maxima, no minima. You can say that no maxima, no minima. That is this point are called point of inflection also we can say. What is point of inflection? Very simple. Point of inflection means the point where the curve is changing its concavity. You see here one of the example x cube. See at x is equal to 0, it is changing its concavity. Concave down to concave up. See concave up. Right, this is concave down. Right, where the function is changing its concavity also you can say that. No maxima, no minima at this particular point. Now, why we are calling this one as nth derivative test? Very simple. You say here, you can go for f4a positive, f4a negative, f4a 0. You can go for it. Positive means mini. Negative means max. Here can't decide. So again you have to go for FIA not equal to 0, FIA equal to 0. FI equal to 0 means again you have to go for the next. But whereas here point of inflection, you can say that no max, no mini at x is equal to a. You can say like that. It will continue in this way. That's why we are going to call it as nth derivative test, sir. You see, last point is global maxima, global minima. I would like to explain with the help of diagram. You see here, I want to define a function with the help of diagram. You see here, let us say that it will continue till here. This is b, this is a, the height is here f of a, this height is what? F of b. Like this, let us take down like this. Here, here, this is what I want to take x1, and this one is x2, and this one is x3, and here I want to take y1, this is what? Y2. I would like to take define like this. What is mean by global maxima? Now onwards I would like to call global maxima is G max, or absolute maxima I would like to call AB max. Right. So now what is mean by G max? Means maximum of, see here how we got this all. Very simple. Y is equal to f of x is a given function. After differentiating y is equal to f dash x, right, after equating to 0, let us assume that we got it like this. X is equal to x1, x2, x3, y1, y2. We got it like this in that interval. And all r belongs to that particular interval if you take. And here you have to take f of a, f of x1, f of x2, f of x3 as well as f of b also you have to take. All the values you take. Right, all the values. Here, you see here I would like to, because almost all it looks like same only. So I would like to change here. I would like to change it this way. Yeah, you can understood in a better way. So that I would like to, okay, that's the reason I made it some changes in that. So here, it is very clear. With the help of the diagram, you can say that where it is maximum means you can say here at x is equal to 3, it will have a maximum value. You are supposed to take f of a, f of b also, though we are after differentiating it, these two a, b are not there, but you have to include that too. Right, out of this all you compare, all are maximum, x1, x2, x3, all will get maximum, right? Out of this all maximum including the boundaries, minimum, okay, including the boundaries, you just compare which one is maximum, that you have to take as answer, f of x3. This is your global maxima at x is equal to 3, at x is equal to 3, right, at x is equal to x3. Global maxima at x is equal to 3 and maximum value is f of 3, you can say like this, right? In the same way, you see here, in the same way, here also I would like to take G mini or AB mini, I would like to write, right? What is that? You see, very simple, is equal to minimum of, so minimum of f of A, f of y1, f of y2, f of b I am going to take. It is not compulsory that we are supposed to get at y1, y2. No sir, it may be boundary also. So what is the minimum here? F of b, you can say that. Because when you compare here, this one and that one, f of b is so small, that's the reason we can take here like this, f of b. Now sir, we discuss here several points in this one, theoretical points. Okay, this is the first part of increasing, decreasing and maximum, minimum. In the second part, we'll continue some good problems and do good concepts also I would like to discuss. Thank you guys.